can see the hand capacitance effect here on 40 meters. It's especially bad. Okay, so that was the first contact on the little rig, 40 meters, 7115. I find that up there above the digital stuff and before the sideband really starts is a good place to do QRP because it's quieter up here, usually in the mornings and in the late afternoons. And it gives you a chance. If you're down around 7040 to 7050, there's a lot of stations, but unfortunately it's very busy down there. A little less busy up here in the old novice band. So whatever you think of this little rig, what Dwight has accomplished here, KW7T, what he's accomplished here is quite an amazing beast. Now, I don't really know how he can possibly be making money on this little transmitter receiver. First of all, if you just consider the woodwork and the point-to-point wiring in hours, that blows the budget before you've even bought the first part, as far as I'm concerned. So the price tag on this does not reflect the amount of work that was put into it. Also, is it technology or is it art? Technology or art? Remember, we're talking about retro QRP. Not state-of-the-art QRP where we have a little circuit board that we can probably buy for $5, put a few parts on it, and you got a couple watts out. It's not like that. This is also a look and feel thing, kind of like that steampunk thing that was going a few years ago. It's similar to that. So the look and feel of this thing is I'm making a contact with this crazy contraption. I'm going to send you a picture of what I'm using, and it's going to blow your mind because your software-defined Flex maybe isn't ready for something like this. And, you know, you can throw stones at the circuit design, but it is proven. Basically, we have the Parasets receiver and transmitter on this board. You know it's going to work because these are proven circuits. Now, can they work better if certain things are done to improve the circuitry, the shielding, the grounding, the bypassing, all of these things? Yes, you can certainly do better than this. If you just built it in a metal chassis, of course, it'd be a big step up probably in ease of use, that kind of thing. You noticed when I made that contact for the opener that as I moved my hand back and forth, I could tune in the signal. Is that a feature, or is that just an artifact of trying to build something on a piece of wood? So I told you I was not going to be sharing the schematic that Dwight puts out, and I'm going to keep to that. I'm not doing anything like that. But I will tell you that I have done some mods to this. Principally, I have put some more bypassing in around the tube sockets, you know, basically bypassing the screen grid on the regen, bypassing the bottom of the choke that feeds both the regen potentiometer and the plate of the regen, just added some bypassing. I also improved the grounding by adding a couple little ground buses between the tube sockets. That seemed to increase the transmit output power a little bit. And I basically grounded the audio reactor, the choke. These are just little things I've done to it to improve the performance. The other thing I noticed is not all of my crystals oscillated or put out the same amount of power. You'll find that the more modern crystals probably have more activity than these. And he does supply a couple of those with the rig, so they should work better. I was just using an ordinary dipole, nothing special on the antenna. You put 3 watts into an ordinary dipole, and you'll be able to make local contacts without much trouble on any QRP rig. Okay, a quick look at the controls. We have the transmit receive switch here, the output tuning for the transmitter. Basically you tune this for the crystal frequency and look for max out on the meter. Then we have the trimmer. This is maximum trim, mid trim, and minimum trimmer. Typically on 80 we want it maxed out. For 40, halfway and up is what I've found for a dipole is right. And then we have the band spread control. So here's the main tuning for the receiver, and here's the band spread control. Finally, the regeneration control to the far right. So pretty straightforward controls on the little TXRX. So one thing I did notice with the receiver, when the transmitter was tuned for maximum output, I was getting a suck out on the regen. And that turned out to be something that we could fix in the transmit receive switch just by shorting out the receiving tank while you're in transmit and shorting out the transmit tank when you're in receive. Very simple to do with a ground centered single pole double throw part of the switch. So in other words, you ground out both of the coils in opposite. So if you're transmitting, you ground the receive coil out. If you're receiving, you ground the transmit coil out. And that prevents the two from interfering with each other. Remember, they're both on the same coil form. This is one of Dwight's innovations, putting both the transmit and the receive coil on the same form. So the onboard multi-vibrator high voltage power supply, very clever. A little bit irritating in the headphones when you're in receive. So there is an extra pole on the TR switch which simply shorts to ground the headphone. Now I cheated with the side tone having a local receiver. I also use that local receiver to find the little beat note of the regen to make sure I'm on the same frequency as the crystal. That's cheating. You'll just have to know what dial markings work out with your crystal and get used to that rather than using a receiver or a counter like I did. You can actually sniff the regen's whistle with a frequency counter. A couple of tricks that if you're in the cabin in the woods or doing parks on the air on top of a mountain, you wouldn't have a receiver or a counter probably at your disposal. The idea of the battery in series with the 12-volt supply, extremely clever. Worked perfectly. 20 volts on this thing, on these pentodes, made a very, very nice smooth regen for CW operation. So all in all, I give this thing probably an 8 out of 10. A lot of fun factor, a lot of classic nostalgia factor, and if you can put up with the hand capacity issue on receive, I think you're going to like this thing as a something to play with on a Saturday afternoon when the signals aren't too far away. So I'm using a 12A6 regenerative stage and a 12A6 transmit stage. As you can see on the power supply with 12 volts, I'm only drawing about a 1/4 amp. That's not bad on receive. once we go to transmit and the multivibrator comes on, this immediately jumps to almost 1 amp continuous. When you press the key and put power out, it goes up to 2 amps. So you want to stay in receive mode if you're on top of the mountain, because you're going to be using a small gel cell or motorcycle battery, or probably 8 D cells to power this thing. Now, if we actually take the 12A6 tube out and we replace it with a 12L6, which actually I find after it warms up, the 12L6 is a more stable regen. Here's your problem. The 12L6 draws 1 amp out of the box. So the price for using the 12L6, which may be a little bit more stable, is that that filament draws almost 4 times as much current as the 12A6 tube. This really is Retro QRP to the max, and a lot of fun. Don't be afraid of the price tag, because like I said, there's no way he can be making money on this thing at $200 for this whole thing, including the crystals. So I did mention the Paraset, and this is what a Paraset looks like. I've built a couple of them and used them on the air and talked to people all over the place on the Paraset. This is not as easy to use as a Paraset, but I can say that Dwight has made the band centered and has better band spread than the Paraset. So even though the Paraset's a little more stable, this guy has got better band spread than the Paraset has, due to the fact he's got the tank elements optimized and the tuning optimized. So I really like the band spread control on this. It works great. As far as tubes go, I tried 12A6s, 12L6s, 12V6s. I even tried 6 volts on here and could get it to receive at least. So it's very tolerant of any beam power pentode. In fact, you could do this whole circuit with a couple of 6AQ5s miniatures if you wanted to. So let's look at the setup with the little transmitter receiver. As you can see, I have it connected to my 2-tube audio amplifier that I've been using in some of my other videos. This amplifier has 2 battery tubes that give it a gain similar to what you would get with an LM386 audio power amplifier. So it's kind of a tube version of that. And it uses a 1U5 connected as a triode as the voltage amplifier, and a 3V4 power amplifier driving the speaker. I have that directly connected to the transmitter receiver, and since it is capacitor coupled, there's no problem, no need for a transformer, there's no high voltage there. It connects right to the amplifier, and that'll give us hopefully enough volume that we can hear signals. Now this receiver uses 12 volts and 9 volts with the additional battery in series, so it operates essentially on a 20 volt power supply. This is the regen stage, and it will work with any beam power pentode like a 12V6, a 12L6, a 12A6, that type of family. And I think I have a 12L6 plugged in. As found, there were some issues with the regenerative receiver, which I have worked on a little bit to try to solve and understand. It was a resonance that was formed by the transmitting tuning circuit. In other words, because the transmitter winding and the receiver winding are in the same coil in this particular transmitter receiver, I was getting a coupling between the resonance of the crystal frequency on transmit to the regeneration frequency on receive. And it was causing kind of a suck out I guess you would call it, where I could not, even with any setting on the trimmer, get the receiver to operate properly as a regen.
But it's more, much more, in the Bible.
Okay, so we have a situation where we have a station tuned in. The regeneration is set such that we can pick up an AM signal.
Beyond the earth during the pouring out.
The tuning control of the transmitter should have no effect on the regenerative receiver.
After verse 4,
But you can see
it's a revelation.
it's having a big effect.
To explain.
We need to break up that resonance. In other words, because we've got all of the coils on one coil form, rather than separating the receiver or the regen coil set from the transmitter coil set, we're getting an unexpected interaction between the transmit resonance and the receiver resonance. So that was solved by making use of an unused set of contacts on the 4-pole double throw switch. There's 4 poles, double throw. That means we can turn 4 circuits on or off simultaneously. So with an unused pair of contacts, I simply shorted out the transmitter coil during receive, and then when you go into transmit, it opens those contacts and it works properly on transmit. So that solved the suck-out problem. Also, I've added a few bypass capacitors that I thought were necessary. Since there is no overall ground plane, as with a metal box, we're using bus wire as kind of a ground system underneath the wooden chassis. And I improved that a little bit and added some bypass capacitors here and there. And that definitely settled the regen down. And I think it might have improved the transmit as well, maybe a little more power out. Of course, at the expense of 2 or 3 more capacitors. And part of building any kit is keeping your part count under control. We can't deliver a kit that costs more to make than we actually get paid for. It's already quite high priced. You know, a couple $100 for a unit like this seems like it's a lot, but when you consider the parts and the labor it takes to both build and test it, it's quite a economical kit as far as I'm concerned. Very difficult to maintain kits. That's a whole video in itself, figuring out how to do kits. Crystals. Now this is a very primitive radio and it's going to require crystals to transmit. You're only on one frequency, so you have to be careful with the regen, which can tune many megahertz of frequency. How do you know when the regen is on the same frequency as the crystal? That's a problem, right? So I'll show you how to overcome that problem. But doing it in the old days must have been pretty difficult with simple equipment. You probably had to use an associated receiver to figure out what frequency your regen was actually on. I'm going to show you how to do it a different way. With a simple transmitter receiver like this, how do you know what frequency you're on? Well, on the transmit side, you know you're on your crystal frequency. But on the receive side, how do you know the regenerative receiver is anywhere close to the frequency where you're transmitting? Other than being very familiar with the receiver and knowing the dial markings, basically you can listen for some reference signals. For instance, the signal on both the 80 meter CW band and the 40 meter CW band, where they do the digital transmissions, is pretty well known, and it's pretty loud. Okay, the signal's pretty strong in the afternoon on 40 meters. So one way we can tell what frequency we are on is by using a counter. Let me turn the counter on. And if we bring a 10-to-1 scope probe and just short the ground to the tip, we form a loop. Okay. Now if we bring that loop close to the regenerative coil, I'm just going to loop it over, we should be able to pick up something that tells us what frequency we're on. Okay, so it says 7038. Okay, 7038. And I know that we're at 7115, so we need to go higher in frequency. I typically keep the band spread dial in the middle, go up to our target frequency. We'll get up there. That's pretty close right there, 7119, so we can change our band spread and get down to where we want to go. Okay, so that's one method. Now once we take the loop away, of course, the frequency will change slightly, but at least we're in the ballpark now. So we know now we're very close to the frequency we're transmitting on, and we could call CQ, for instance. Okay? Another way would be to use a radio receiver. So if we have a radio receiver, and we set the radio receiver to the crystal frequency, okay, if we transmit, we can actually hear the tone, okay, and now we should be able to hear the regenerative receiver's beat note. If we can get this close enough, we can probably pick it up. Let's see if we can pick it up. Okay, so we're definitely able to hear the beat note in the receiver. So we know that the receiver's tuned to the same frequency as the transmitter now. So that's another way to do it. Use an associated receiver to sample a little bit of the regen's energy coming out.
On the 160 meters output. Yeah, it's working good. You have a very soft voice, Dennis. If you could bring your voice up into a little louder voice, you'd probably you're F7, but like I said, you have that soft voice that doesn't sound like an S7. Over.
Yeah, okay. Well, I'm on the ICOM 7300. Mic gain is at 30%, and I run my compression about 3. But when I look at the ALC,
and it runs up and inside, and now Gore's behind 3-1, in danger of bringing the Tiger to the plate if he
So with the 160 meter coil, we can actually hit the top of the broadcast band. This is 1500, coming in nicely. Yes, folks, I did some mods to make it basically usable, and these were all reviewed with Dwight. There's more certainly that you could do. This is a unit that's easy to work on. But I want you to be very careful under the chassis, because with that multi-vibrator step-up power supply, some high voltage is present. So I hope you've enjoyed this little trip into a product that you can get online. Always nice to be able to play with something that somebody else has engineered and put out there for you, totally wired. I can't imagine someone having to build this as a kit. I suppose it could be done, but it would be very tricky as a kit. With the wooden chassis, I'd be wood burning more than soldering.